or good afternoon. We're here for part 2 of our matter and change video. We're again looking at the properties of matter. And today we're actually going to spend some time talking about the states of matter. We want to be able to actually look at them and describe them in terms of their particle movement, the arrangement, the shape, and volume. So let's jump into it. Now, we've always been very familiar with the states of matter. We usually hear about it all throughout middle school and even in elementary school when we talk about solids, liquids, gases. But now let's look at it in a couple of different ways. The first thing we're going to look at is when we deal with our solids, we're going to notice that they're going to be tightly packed. Now, when we look at a solid on the regular day, like our tables in class or even our shoes, we don't think of it as particles. We usually think of it as this solid material. But if we can zoom all the way down to the atomic level, we would start to see something that may look a little bit like this. Now, how would you describe this? Well, notice everything is nice and lined up and ordered, very, very close together. And you wouldn't be able to tell from this picture, but they're actually moving. Now, why would the particles be moving? We're going to actually deal with that a little bit later, but we have all these atoms with their electrons that are bumping into each other, and they're causing some repulsion, and it's going to cause it to sort of vibrate a little bit. If you increase the heat, they're going to vibrate faster. If you decrease the heat, it's going to vibrate slower. But we haven't gotten to a point where we haven't gotten them move, where they don't move at all. Now, they're vibrating in a fixed position, meaning they're staying still, so they're still staying very huddled together. Now, how can we describe the shape of a solid? Well, we say they have a definite shape, or they hold their shape, and they have a definite volume, meaning whatever amount of space it takes up, even if we grind it all the way down to powder, it still takes up the same amount of space, and it will still hold whatever shape that it's originally in. Next, we want to move on to liquids. How are liquids different? Well, as we see in our description, they're still tightly packed, and we can see this in the image here, but they're far enough away where they can actually slide around each other. That's what you're seeing happening here. So we have a little bit less order to the system, and the particles are moving around. I liken this to people trying to move around during passing period. Everything is nice and cramped. There are lots of people gathered in very close, but there's still room for you to go by. Now, when we talk about shape and volume for liquids, this is where things become a little bit different from our solids. If we look at it, it says that liquids have an indefinite shape. An indefinite shape means that it takes on whatever container you put it in. So if I pour a liquid into a cup, it'll take the shape of the cup. If I then take that and pour it into a bucket, it'll take the shape of the bucket. And then if you hold your hands out and I try to pour it into your hands, it'll take the shape of your hands, but if it can slide through, then it'll fall all over the place. This is what we will call an indefinite shape. Now, what about volume? Well, volume is saying, can it be compressed? So, even though our water, if I pour it into a cup or a bowl or into your hands, even though it'll change shape, it still will take up the same amount of space. So it'll change shape, but it still takes up the same amount of space. So we'll say that liquids have an indefinite shape, but it has a definite volume or consistent volume. We can't change that about it. Now, moving up the scale, we're moving on to our gases. Now, if we look at the particle diagram of our gases here, you notice that they're a little bit more spread out. They're able to move very freely. And they sort of bounce off each other, just like little kids full of sugar. Now, in terms of shape and volume, if you look at it, notice that it says that gases have an indefinite shape and an indefinite volume. If you recall just a few moments ago, we said indefinite means that it doesn't hold its own shape, meaning I could pour it or put it into any different container and it would take the shape of that container. This is why we can fill our footballs, basketballs, our tires, our lungs with with different gases. When we breathe in, the gas fills up our lungs and takes that shape. When we breathe out, it goes out into the atmosphere and takes on the shape of whatever it happens to bump into. Now, what about volume? This is the first one we're going to deal with where we can actually compress it. So, if I start off with my gas blown into a balloon, I can then take that balloon once it's been tied up and squeeze it, and I'll notice that the volume of the balloon, or the size of the balloon, gets a little bit smaller. This is because it has an indefinite volume. This is also because, you notice we have a lot of empty space in here. The more empty space, the more you can compress it. The less space, like we have with our solid and liquid, the harder it will be to compress. Now, we have one last state of matter, and this is one we'll introduce you a little bit more to as time goes on, and that's plasma. Now, a plasma is just an ionized gas. So we had our gas just before, but this is going to be a gas that has ions all the way throughout. That's what these plus signs and minus signs actually are. Now, these are going to be very, very good conductors of electricity. Why? Because even though they're spread out over such a large space and moving so fast, they have these charges in there that are going to help them to actually be good conductors. Now, in every other way except for that, a plasma is just like a gas. It has an indefinite shape and an indefinite volume, meaning it can actually be compressed or expanded, and it'll take on the shape of whatever it is that you put it in. Here you should see the examples. We have stars that are examples of plasma, as well as our particle diagram. Take some time, review what we've gone through today, and we're going to finish everything up tomorrow with a little activity. Just as a wrap up, one of the things I want you to notice is, as we went from solid all the way to plasma, the particle energy of the movement of the particles increased. So the solid would be the least, then liquid, then gas, then plasma. So my question that I leave you with is, if I start off with liquid water and I freeze the liquid water into a block of ice, which direction did my particle energy go? Did it increase or did it decrease? I'll see you in class for the answer. Have a great day.